ओम नमो शिवाय। शुभ मध्याह्नम्। अधुना वयं शैक्षिक अनुसंधान विषये द्विसप्ताहिक कार्यशालायाः नवमदिनाङ्कस्य तृतीयसत्रे स्मः। अस्मिन् सत्रे सर्वेषां गुरुभ्यः प्रियछात्रेभ्यश्च स्वागतम्। विविधकार्यनियुक्ताः व्यस्ताः सत्त्वेव अस्माकम् आह्वानं स्वीकृत्य आगतवत्याः प्रोफेसर एन कलरै आरएससी महोदयेभ्यः पुनः एकवारं स्वागतं व्याहरामि। महोदय अस्माकं परिचिता एव। इतः प्रातःकाले वयं ज्ञातवन्तः, अतः वयं साक्षात् पश्यामः महोदय अस्माकम् अधुना किं बोधयन्ति। परन्तु अहं सामान्यरूपेण वक्तुं शक्नोमि यत् महोदय अधुना अस्माकं शिक्षानुसन्धानस्य अन्तर्गत पैरामेट्रिक टेस्ट एज्यूम्शन्स् मध्ये ई टेस्ट एवं जेड टेस्ट विषये विस्तृततया बोधयन्ति। अतः महोदयाभ्यः अनुरोधे भवत्याः वीडियो प्रस्तोतुं प्रकटयन्ति इति सम्प्रार्थये।
Yes, yeah. The first one. Yeah. Go down. You'll find students. Previous. Go 3 slides up. No, down. I think 21, if I'm right. 21. 20. Ah, okay, yeah. Yes. Because the last bit of last session. I am happy to meet you all again with the same enthusiasm and same focus towards this research. Now, morning we have discussed about normal property curve, which is a bell-shaped curve in which the mean, median, and mode maintains a perfect balance. Suppose the balance shifts, okay? It gets distorted when the curve, as you were rightly pointing out in the morning, if suppose the mean, median, mode vary, what will happen? It will become an asymmetric curve, which is known as skewed distribution or skewed curve. When it distorts from normality, when mean and median and mode shift from the same point, when they coincide, perfect balance is maintained, 50% here, 50% there. When the shifts, when the mean deviates from the median, always median divides that into 2 equals, but mean and mode vary. Okay, when it shifts from the normal position from the central orient to one end, either this way or that way, you will get a skewed distribution. So we find the skewness. We find the degree of distortion. I think I'm audible. You will find the degree of distortion with the help of computing skewness. Okay? So your distribution of skewness is not symmetrical. It is said to be asymmetrical distribution. Okay? Or skewed. By skewness we mean the degree of departure from the symmetry. Degree of change over from the symmetry. Okay? So a distribution is said to be skewed when the mean and median falls at different points in the distribution, and the balance, that is the point of center of gravity, shifted from one side to the other, either to the left or to the right. And the distribution which mean, median fall in the different points is known as the skewed distribution. Methods of distribution skewness gives 2 things. One is degree, another one is magnitude. To what extent it is shifting, to what extent it is skewed, magnitude of the distortion, and also degree, it is negatively or positively skewed. So which is close to the heart of any researcher is negatively skewed distribution. Okay, for any teacher or for any researcher, the one which is close to the heart of any researcher is negatively skewed distribution. We will come to this later why it is negatively skewed. Yes, go further. Next one. The distribution in which most of the frequencies are concentrated in the classicals bearing the lower values. Suppose in a frequency distribution, you have more number of frequencies in the lower class interval, then you will get a positively skewed distribution. For example, 10 to 20. You know frequency table, right?
Yes.
Suppose this is a frequency table, class intervals 7, 9, 3, 2, 1, 1. So more frequencies falling towards the lower class intervals. When you have this kind of distribution, you have positively skewed distribution. You get the point? So when you have more number of frequencies towards the higher class intervals, you will have negatively skewed distribution. Okay, more concentrations towards the 4, 2, 1, 0. Suppose you have like this, then this you will have negative skewed distribution. That's all I given here. So when the curve obtained from the distribution is called a positive, the distribution in which most of frequencies goes on constituted in the class interval having the higher values. Having the higher values is known as a negatively skewed distribution, and the curve drawn on the basis of distribution is known as negatively skewed curve. Yes, going further. Next one. So the formula to calculate skewness. 3 times mean minus median by standard deviation. So it totally depends on the mean. In the normal curve, mean, median, mode falls in the same point. It is one and the same. So 3 times mean minus median. Mean, suppose mean is 40. What is the median for the normal distribution? Mean is 40. What will be the median for the normal distribution?
2 halves. So 30 means 15.
This is going to be a question. The mean of a distribution is 40. What will be the median of the distribution?
Median of
Median will divide into 2.
Yeah, it
So
divides
40 means
into 2
20.
equal halves.
Yes.
2 equal
The
halves.
mean value is 40.
Yes.
What will be the median value?
20.
In a normal distribution, mean, median and mode coincide.
Coincide. Okay.
Then
That's
what will be
same.
median? 40.
40. Same.
Median also be 40. Is it not? You saw the curve, mean, median, mode, all the three falls on the same point. Okay, so when the mean is 40, median is also 40. Then what will happen to this value? 40 minus 40? 0. 3 into 0 divided by any standard deviation? 0. That is why the skewness of the normal distribution is 0. Okay, that is why it is not a skewed curve. It is a normal curve. Normal curve can never be a skewed curve.
Yes.
Because the reference curve itself is normal curve. When it is deviated from the normality only, you are going to have skewness. So skewness is 0. So skewness of a normal curve is 0. So the formula to compute skewness is 3 times mean minus median by standard deviation. Other formula in terms of percentage also you can calculate. That is P90 plus P10 divided by 2 minus P50. This is another formula to calculate skewness in terms of percentage. What is P50? What is P50?
Percentile.
What is 50th percentile? Alert after lunch.
Q.
Q2. Post lunch should be alert. P50.
Q2.
Q2. What is the other name for Q2? I am expecting the answers from this sample. I think this is student sample, this is faculty sample. Am I right?
Front or faculty, back or students.
Okay.
Today is Women's Day. So they should be
Maybe
hyperactive.
Women's Day, yeah. That's correct. Women's answer. What is P50? Morning we read all that.
Q2, I think.
Q2, what is the other name for Q2?
Middle of the
What is the middle?
median.
Median.
Right.
Okay, P50 is median. Is it not? P25 Q1, P75 Q3. So the formula is P90 plus P10 divided by 2 minus P50. That is median. Okay, this is the other way of calculating median. Clear? So when will you get positively skewed curve from this formula? You tell me when will you get positive skewness? From the formula you try to tell me when will you get positive skewness?
Highest.
When mean is greater than the median. When mean is greater than the median, you will have positive skewness. Because standard deviation can never be negative or positive. Because it's a square root value. We are not going into complex numbers now. Square root of negative number will become complex numbers, mathematics students must be knowing. So standard deviation will always be positive. So the sign is decided by only the numerator. Because this is always positive. The sign of the skewness value is decided only by the numerator. The numerator, when the mean is greater than the median, you will have positive skewness. When the median is greater than the mean, you will have negative skew. Okay? Yes, go to the next one. See, when mean is greater than the median, greater than mode, you are having a positive skewness. This is the positively skewed curve. I have given the first statement. When mean is greater than the median and greater than the mode. So, mean is here, median is here, mode is here. Mean falls in the higher place. Okay, when mean is greater than the median, greater than the mode, you will have a positively skewed curve. So, you have the right tail of the curve is longer than its left tail. When they are net or product on this graph, the formula of skewness and this coefficient gives the positive figure. Okay, this is not advisable. This is not needed for the researcher. Why means, see, you have the median here, you have the mean here. This is the class average. See, below the class average, so many students are getting scores. Do you get the point? It means many students are failing. This is the average. So only few students are getting through the examination. So many students are failing. That too, this is 50%, no? Even more than 50% students are failing. So this is not close to the heart of the researcher. This is not expected. Always we try to have negatively skewed distribution. Do you get the point? Okay? Yes, going to the next one. The characteristics of the positively skewed curve. Suppose you are getting a positively skewed. What is the inference you will draw from the positively skewed value? You are getting a positive value. Your mean happen to be greater than the median. You are getting the answer. What is the inference from that? Always researchers should seek for some inferences. There is a difference between interpretation and inference. Interpretation, when you write what is given in the table in a worded form, it becomes interpretation. But if I write what I understand from that, that becomes inference. Even morning, the other resource person was telling how to write review of literature. You should not just copy from others' work. You should try to understand, assimilate and give your own way of writing. That becomes OOL. Like that, inference is drawn from your understanding. What you infer from the value. What is this is positive, this is negative, this is only interpretation. Inference at the higher level. Researchers are expected to give inferences. So what is inference? Graph drawn from the source of the classroom in which there are low achievers or failures shows positive skewness. That's why it's more number of failures are the low achievers of the class. Then you will get positive skewness. And next, if the subject is difficult and most of the students would not understand, or the teacher is not able to do justice in the classroom, the teacher is not efficient, then you will get positive skewness. You have to accept our limitations also. Okay, and if the teaching is ineffective and the students did not prepare well for the examination also, you will get positive skewness. And if the evaluator or the examiner did assign fewer or less marks to the examinees, there are examiners who gives only less marks. Okay, it doesn't mean liberal. They are very stringent giving marks. So if they give that kind of marks, you will get positive skewness. And finally, the question paper consists of questions having the higher difficulty level. When difficulty level is very high also, you will get only positively skewed curve. So these are inferences which you should generally draw from the positively skewed curve. Clear?
Students, one who is not at all having interest on the particular subject.
Yeah, definitely they will also fail. They will also fail. Okay? Yes. Going to the next one. Negative skewness. It is reverse. When mean is less than the median, less than the mode. Here in the formula we saw. When will you get negative skewness? When mean is less than the median, you will get negative skewness. Mean is less than the mean, you will get negative skewness. So mean is less than the median, less than the mode. You will have negatively skewed curve. So this is the negatively skewed curve. So your mean, your median, your mode. See, above mean, so many students are getting scores. See, this is median. Above this, 50%. So more than 50% are getting marks above the class average. So negatively skewed curve is not expected out of the researcher. That's why I said it is close to the heart of the researcher. You expect only negatively skewed distribution. Clear? Yes or no?
Yes, ma'am.
Yes. Going to inferences. Next. scores of the classroom where there are intelligent and studious students shows a negative skewness. So if the students are so intelligent, studious like you people, definitely you will have negatively skewed distribution. Next, if the subject is easy, please. If the subject is easy and understanding of students better than that, sorry, this is TSA, better than that, students shall score higher scores, higher marks in the subject. So subject is easy, they are able to score very good marks. And teacher is also very effective in the classroom, you get negative scores. And finally, if the evaluator exam is very liberal in giving marks, then you get it.
That is correct, but then before better, after better, a comma should be there.
Yeah, better comma. Better than the students shall score higher marks in the subject. Okay? These are the inference you draw from the negatively skewed curve. Yes, we'll proceed. Next one is kurtosis. So we are saying about the skewness. Skewness is an asymmetrical curve which deviates from the normal curve. A curve which deviates from the normal curve is skewed curve. It can be either positively skewed or negatively skewed.
Okay, ma'am. More students fail. That we call as a positive Q.
Yeah.
More students going above marks, we call as a negative skew.
Yes.
Yes.
What is the skewness there? The mean line is the skewness.
No line is indicated by skewness. No line is indicated by skewness. Only the value magnitude will get.
Okay.
You will get the magnitude, the degree also shown either negative or positive. It is not the person of any line like the mean, median, mode. No.
Okay.
Okay? It can fall at any point. Yes, next one. This I have given the comparison. This is symmetric curve. Top curve is normal curve. This is symmetric, normal curve. These two are deviated curves. Like skewed to the left, this is negativity. Skewed to the right, it is positive. Clear? Okay? This you can find the distortion. Shifting of balance. Okay? Yes, sir. Now we'll go to the next aspect of it, kurtosis. So skewness, when you talk about NPC, you have to talk about skewness and kurtosis. Okay, with reference to NPC. What is kurtosis? The peakedness or flatness of a curve than the normal curve. Okay? If the curve is very peaked or very flat, we call that as kurtosis. The peakedness or the flatness of the curve. The kurtosis distribution refers to curvedness or peakedness. The two distribution may have same mean and the same variance. What is variance? You know what is the variance? What is the variance?
Difference between higher and lower score.
Sigma of x minus x bar the whole square by n. To what extent individual scores deviate from the average score? The squared root of that divided by n. Okay, variance is nothing but square of the standard deviation. So variance is nothing but SD square. Okay, that is sigma squared. Then what is the standard deviation? Square root of the variance. Standard deviation is square root of the variance. Suppose SD of a distribution is 25. What is the variance? SD of a distribution is 25. If a standard deviation of a distribution is 25, what will be the variance? 625. Okay? Square of the standard deviation is variance. Okay, if a variance of a distribution is 81, what is the standard deviation? 9. Okay, variance is 81, so square root of it is 9. Clear? This is the relation between. So in a curve, if the mean are the same and variance is also the same, may be equally skewed because mean is variance is same, but one of them may be more peaked than the other. So there you get kurtosis. Mean is same, variance is same, but peaked. One is more peaked, one is little flat. You will have kurtosis. The peaked is based on the degree of concentration of the scores near the central tendency. How far the scores concentrate near the central tendency is shown or displayed through kurtosis. I don't know if you understand. The normal curve is generally known as mesocutic curve. The normal curve is known as medium pickedness. So mesocutic curve. It is not very picked, it is not less picked. Medium picked. So it is known as mesocutic curve. A distribution having high concentration of scores near the central tendency and high tails as compared to normal distribution with the same standard deviation is called as a leptocutic curve. Lepto means narrow. Okay? So more concentration towards central tendency. See, more concentration towards central, but it is picked. So that is known as leptocutic. Okay, this is normal curve, is it not? Normal curve is known as mesocutic. So more concentration, so more picked here is leptocutic. Okay, the other one is which is flat. Concentration was central, but it is flat. It is known as platycutic. So this is platycutic. Okay, platy means flat. That's why I given here. Flat or broad or wide. Okay, so there are three types of curves: mesocutic curve, platycutic curve, and leptocutic curve. So let's go to the next one. Next slide.
Next slide.
So the mesocutic, the kurtosis of a normal curve is the formula. The formula to compute is Ku, kurtosis Ku equal to quarter deviation divided by P90 minus P10. 90th percentile and 10th percentile. Quarter deviation divided by P90 minus P10. This is the formula. 90th percentile minus 10th percentile. The formula to compute kurtosis. Next slide.
No, next.
Yes, please. Previous one. So whenever you talk about normal property curve, you have to think about skewness and kurtosis also. Okay, they are going hand in hand. NPC, kurtosis and skewness. Yes, next one. See, I have given the curve. The leptocutic curve, mesocutic curve, and platycutic curve. Okay, so the skewness, kurtosis versus normal curve is always 0.263. It is always 0.263. Now, kurtosis value of a normal curve is, there is mesocutic curve is 0.263. When the value is more than 263, it is known as leptocutic curve. When it is less than 0.263, it is platycutic curve. Okay? Suppose the kurtosis value of a curve is 0.281. 0.281. What kind of curve it is? Huh? 0.281. Leptocutic. Okay. Suppose the kurtosis value of a curve is 0.243. Platycutic. Okay. If a point, the kurtosis of a curve is 0.263. It is mesocutic or normal. Clear? This is what it is. You can have platycutic curve, leptocutic curve, or mesocutic curve. Okay? But what is expected for any researcher? Generally, for doing high level of research, which kind of curve is necessary? Mesocutic. Normal curve is only necessary for doing a good research. Okay? Yes. This is about kurtosis. We're going to the next one. I think this I have inference that can be drawn from the kurtosis. What I can understand from kurtosis? First one is, most of the students in the group are average. There is mediocre students. When you have leptocutic curve, most of the students are average students. Okay? And intelligent dull students are less in number. That's why it's speaking here. Intelligent students are less in number when you have leptocutic. And the examiners allot average marks to most of the students. Some examiners will correct, they will give only average mark. They don't not bother about the quality of response. To be on the safer side, out of 5, give always 3. Either he writes well or poor. This is not. So when the examiner corrects in such a manner, you will have leptocutic curve. And next, the teacher must have used only one method of teaching, leaving the individual differences. The teacher need to adapt to the individual differences in the classroom. So when you adopt only one method of teaching, you may have learned with this leptokutic curve. Questions is more or less similar difficulty level may be given, may be included in the question paper by the examiner. So the question paper need to be heterogeneous in the difficulty level. Always all the questions should not be of equal difficulty level. All the questions should not be easy, all the questions should not be difficult. There should be scope for students to write, different students to attempt some challenging questions also in the question paper. High difficulty questions. Some easy questions should be there, more of average questions. So your question paper should also fall with the normal curve. When you look at the difficulty level of the question paper, you should also fall within NPC. Then it is a standard question paper. Okay, of course, we are not bothered into all those things when you are, because I also work as a control of examinations for more than a decade. So examiners are not bothered about all that. Okay, in fact, to tell you truly, they have to adapt to that.
In internal mark, we will get leptokutic curve, but in
External, you will get flatty. You will get flat.
below average as leptokutic curve.
Yeah, flatty, that's what flatty.
Flatty, yes.
Yeah. Okay,
You can see by seeing our mark list.
looking at the marks, you will know. Yes, that is correct. Internals, you will get so as a result, you will get negative correlation. We will try to put correlation for internal and external. Sometimes we land with negative correlation. What does it mean? A person who is getting 18 out of 20 should be able to get 75 out of 80. But a person who gets 45 or 35 out of 80 is getting 18 out of 20 in the classroom. The internals. You land only with the negative correlation. It shows the objectivity of the examiner, both internal and external. Okay? Yes. Yes. Next is questions which are more or less similar difficulty level must be included in the question paper by the examiner. Next, the discriminant index. You must study about difficulty level and discrimination index. The discriminant index of the question paper selected is very less. It is not able to discriminate between people who know more or who know less. A good question paper should have high discrimination index. The question's marks should be able to distinguish between people. These are people who know more. These are people who know less. But when the DA value is less, you will have leptokutic curve. And next one is the examiner may have allotted more or less similar marks to the examiners, as I told you earlier. More or less similar marks to all the examiners. All the students were taken with the exam. Okay? So these are inferences drawn out of leptokutic curve. Yes, next slide. What are inferences that you draw from the platykutic? This kind of curve. So what is the inference? What is the understanding about the platykutic curve? Questions including the question paper may not have been framed following the general trend. Okay. So normal general trend is not dropped in the question writing the question papers. The teaching is ineffective. When the teaching is ineffective, you will have platykutic curve. And valuation papers may have been improper, not adhering to the proper scoring key. The valuation is not objective. Then you have this. DA, discrimination index of the question asked in the examination may be of higher order. When DA is very high, you will have platykutic curve. It's not able to distinguish mark. There may have been a variation in difficulty level of the questions, and the group of students is heterogeneous, not homogeneous. You will have all sorts of mixed kind of students in their classroom. In all these are inferences you can draw out of platykutic curve. Mesopotic, you know very well. They studied about the properties of the normal curve. That is only inference. Mesopotic is a normal curve. Morning we are discussing in detail about normal curve. So these are inferences we draw from the kurtosis values. Clear? This is over. I think I have completed this. Yes. Okay. We go to second PPT. The second session given to me is T test and Z test. Parametric test. Yes. What is parametric test? In order to understand parameters, we have need to know certain notions, certain understanding of the basic concept. What is parameter? What is statistics? What is a parameter? Any numerical quantity that describes about the distribution. So a parameter is a numerical quantity that characterizes a given population or some aspect of it. Most of the common statistical parameters are mean, median, mode, standard deviation. A numerical quantity which characterizes the distribution is not known as parameters. Okay, we follow. What are the parameters of the individual human being? What are the parameters of individual human being? Height, weight, IQ, your IQ, your color. These are the parameters which describes about your characteristics. So which characteristics is called of population is known as parameter. So a parameter is a number describes the whole population, where statistics is a number which describes the sample. When it refers to the whole population, it is parameter. When it refers to only a group of individuals who represent the whole population, that is sample, it is known as statistic. The statistic is a numerical value calculated from a sample of data, but it represents a summary of characteristics of the sample and is used to estimate the corresponding population parameter. From the statistic, I can find out the parameter, population parameter. From the population parameter, you cannot find out the statistic. From the statistic, you can go to the parameter. We follow. Knowing the statistics, you can estimate the population parameter. Statistics subjects to sampling variability, meaning they can vary from one sample to the another. But population is unique. Population is not only one whole universe. It cannot keep changing. But statistic value can change, keep changing. Because it varies from one group to the other. Because sample differs. Is it not? So it may vary, but parameter will not vary. Okay? Yes, next one. There are certain notions, symbols used to represent parameters and statistics. Generally, Greek letters or capital letters are used to denote parameters. Latin letters or lowercase letters are used to denote statistics.
Statistical notation is
How you denote? How you denote? Suppose SD. How you are denoting SD? Sigma.
sigma,
Notation. X bar mean.
mean,
Okay. So when I write X bar, it represents sample mean. When I write mu, it represents population.
population,
Like that's one notation. So statistic notation is
statistic,
both parameter, both for whole population as well as for the statistic. I can use, we can generally, this is only general notion. Use 3 Greek letters or capital letters to indicate population. Use lowercase letters or Latin letters to indicate sample statistics. So I have given this. Proportion is P hat, small p hat, capital P is population parameter. Mean is X bar, whereas mu for population. Similarly, standard deviation, S Latin letter, sigma Greek letters for parameter, for population. Variance S squared, sigma squared. Understood? So these are common notation used by all the statisticians generally. Yes, next slide. Assumptions of parametric test. Whenever you want to apply a parametric test, certain conditions should be fulfilled. Otherwise you cannot apply. So what are assumptions should be considered? Should be tested before applying parametric tests. Because parametric tests are of higher standard. Okay? There are more sophisticated statistics. So they need to undergo certain conditions to that. First is, first condition is normality. You should check for normality. So data in each group should be normally distributed. First condition to be checked is data should be normally distributed. Okay, you have to check for the normality of the distribution. If you want to apply for, that's the morning your director was also pointing out. When you want to use parametric test, it has to undergo certain, it has to fulfill certain conditions. First condition is normality. Check for the normality. If it's not normal, don't go for parametric test. Do the data collection again, or you see what is disturbing the data. Maybe more outliers might be there. Okay, so the statistician will check for normality generally. First condition. So data in each group should be normally distributed. Parameters assume that each group is roughly normally distributed. Okay, this is the first condition. Second condition, equal variance. So both the groups, the samples adopted should have the equal variance, approximately equal variance. 42.2, 42 point not necessary. 42.2, 41.97 okay. Or 41.3 okay. Okay, but the two groups should have approximately equal variance. And third condition, if you want to check that, the ratio of the larger variance to the smaller variance, you can check if it is less than 4, then you can consider that to be the equal variance. Suppose one distribution has got variance value of to check for whether the variances are equal or not, suppose distribution 1, it has got a variance of 7.2. Distribution 2, it has a variance of 1.4. Okay. Now you divide the first variance divided by second variance. You tell me what is the value?
$5.14.
5.14. This is value less than 4 or greater than 4? Greater than 4. So that these two groups are not equal variance. They are not equally variant. This is not equal variance. So second condition failed. No, I cannot apply parametrics. This is one way to check the normality. Variance, equality of variance. Okay, when the proportion of the first variance to second variance is less than 4, then you can consider the two distributions are equally, equal variances. So I can proceed with the parametric test. And third one, independence. Data in each group should be randomly and independently sampled from the population. Verify the data was collected using a probability sampling method. If you go for incidental sampling, definitely you will not get normality, you cannot apply parametric test. As and when available school, when you get into the school or you get into the college, there you know the HOD, he only gives you permission, you go to the particular class, administrative tool will come up. That's going to be incidental sampling. It is not random sampling. Do you get my point? Okay. So when you don't apply random sampling method, there is very big question mark of checking for normality, checking for going for applying the parametric test. When you apply any kind of any random sampling technique, then the third condition will be satisfied. Independent, because I am not including any subject in my research due to my will and whims and fancies. Due to my will, I applied a scientific procedure to select the subject from a sample. Do you get my point? Yes, that is known as independence. Now, last one is no outliers, no extremities. There are data which is very extreme. When the statisticians check for normality, they try to limit the outliers. For example, three, 4, 5, 6, 7. What does it mean for this? What does it mean? 5. 5 is the mean. Okay. 3, 4, 5, 6, 18. What will be the mean?
There is also 5.
This is also 5. How come? I am asking you the mean. How will you find the mean? Add everything divided by 5. I am not asking you the median. You are talking about median. Only the median, you arrange them in the either descending order or ascending order, you pick out the middle one. That is median. I am asking you. I am asking you mean.
Mean, okay, average.
86, 91,
19.6.
19.6. 19.6. So, this is outlier. See, it will distort the distribution. Do you get the point?
Yes,
This is the normal distribution. Mean and median is same. Yes or no? Yes. Mean is also 5, median is also 5. This is a normal distribution. This distribution is skewed distribution. It distorts, just pushes the curve on the other end. This is known as outliers. Very extreme. Okay, behaving very indifferently. Okay, that is outliers. So there should not be no outliers to apply normal distribution. Clear? So these are the conditions to be fulfilled to apply parametrics. Yes, next one. So there are a number of parameters that I given with you. One sample 2 test, 2 sample 3 test, ANOVA, ANCOVA, MONOVA, 2-way ANOVA. All these are parametrics. There are 5 standards. So first you get the statistics. Okay? Just I gave you a number of tests are there. Now we are passing on to t-test. So I have given the basics for parametric test. Now we are pushing on to t-test. What is t-test? Student t-test. T-test we try to find whether there is any significant difference between two groups. Whether the two groups are drawn from the same population or from the different population. Do you get the point? I think somebody already discussed about T-test in the earlier class. Okay? So, I just, over here you want to check up only this. I gave you 4 examples, 4 criteria to adopt the T-test law. The 4 criteria should be tested here also. Normality, homogeneity appearance, independence, scales of measurement. The scale of measurement for data to be applied T-test should be either continuous or ordinary scale. Here you can have some interval ratio scale also you can use for applying T-test. Applying T-test. Okay. Now sample size. Hey, this really large sample should be used to apply T-test. When the sample size is very small, that's a small deviation in the formula. Okay. So in T-test you can apply for based on the sample size also. Relatively large sample. Large sample in statistics we refer to more than 30.
Ma'am, more than 30 sample can be used generally Z score, na?
Z score, T-test for parametric test you can use T-test. Yeah.
Generally more than 30 we have to use.
Yes, Z score. Z score you compare combined distributions. Suppose you want to compare 2 different samples where they differ in the particular way. Maybe 180, 200 students T-test only will apply. Yeah.
Generally we understand more than 30 sample we have to go for that test.
That's one condition, sir. You convert them to standard scores and use it. For all the research purposes, when you have 2 samples, more than 30, large sample independent sample T-test there. When it's less than 30, you will use sigma root of n minus 1. Small sample, this experimental group, where the group size is less than 30. There you use student T-test with small variation in the.
Where we have used that test?
To convert to the standard score and then compare.
For large samples.
Large samples.
We have to clarify in regard to this point.
Yes. Next one. You go to the next slide. The dependent variable should be measured in the interval of the ratio. First, this I am taking one sample T-test. Only one group. Okay, one group before and after treatment. Experimental group. Only one group you are having pre-test, giving the treatment, then post-test. Only one sample. Okay. So the dependent variable should be measured in the interval or ratio scale. What are the 4 scales of measurement? Nominal, ordinal, interval, ratio. Okay. Most of our psychological tools are land with the interval. Yes, exactly. The scientific physical quantities for science, physics and all, you land with ratios. Okay. The data are independent, not correlated, which means that there is no relation between the observations. When the data are not related, independent of each other, then you go for one sample T-test. Because with no intuition, we have included it. Okay? Next. There should be no significant outliers. I said told you earlier. There should not be any significant outliers to apply one sample T-test, only one group. Pre-post design. One shot design. Experiment design, professors want to discuss. One shot design. Okay? Pre-post design. Yes, next one. What are the procedure to adopt for computing or applying T-test? First, writing the null hypothesis. There is no significant difference between the pre-test and post-test scores of the sample who have been treated using this particular method. Okay? Next, computation of standard error of the difference, SED. Second step is you have to compute the standard error of the deviation. Using third one is compute CR. The CR formula is M1 difference M2 divided by sigma D. That notation is difference symbol. This is difference, not minus. What is when we make difference? You have to subtract the lower one from the bigger one. CR value should not be negative. That's why professors will say when you put it in the thesis, don't put negative for CR. Don't put T, negative value for T. The professor used to say. Our CR concept is subtract the smaller one from the bigger one. That is only that. It is not minus. That is why we are using symbol, difference symbol, M1 difference M2. Divided by sigma D. Now you have to find the degrees of freedom. Always, when you do a parametric test, the obtained value should be considered with the table value. Okay, in order to refer the table value, we need degrees of freedom. DF. What is meant by degrees of freedom? What is meant by degrees of freedom? What is your understanding about degrees of freedom?
Mean value.
N minus 1, R minus 1, always minus 1, minus 1. Okay, why it is N minus 1, R minus 1, K minus 1 and so on. See, suppose I have a set of data, I have set of 5 data whose sum should be 20. So I am giving you 2 conditions. 5 data should be there, its total is 20. Okay, come on, start giving values. One by one, just give values. 4, 7, 5,
2,
2,
1, 9.
9. How can it is 9? 2 by 2.
Total 20 should be
Totally
there.
20.
Five.
So far you are able to give freely values.
Yes.
But this you cannot give. This is decided by the condition. Total of 5 scores. There are only 5 scores, the
20.
total is 20. So you have the freedom to give only n minus 1. That is why degrees of freedom is n minus 1.
Once more.
See, I have given 2 conditions. There should be only 5 data. This total will be 20. Arbitrarily you are giving values. 4, 7. You give some other values, so we will put no other, no issues. You will have the freedom to give 4 values. 5th value you don't have freedom.
2, 1.
Why?
Why? The total should be 20.
2.
The total should be 20. You add up all this, after this you are getting 18. Can I give 4 here? No.
2.
I can only give 2.
Yes.
So I have the freedom to choose only 4 values. Out of n, when n is 5, you have the freedom to choose only 4 values. The 5th value is automatically decided by the conditions imposed. That is why degrees of freedom is n minus 1, r minus 1, k minus 1 and so on. Always minus 1, minus 1. Understood?
2 groups and minus 2.
N minus 1 plus n2 minus 1. N1 minus 1 plus n2 minus 1. Here 4 freedom, there 4 freedom. That's why T for DF for T is N1 minus 1 plus N2 minus 1. Understood?
Right.
These are basic. Understand? Generally we miss this when we take the class. Okay? Yes, next. So comparing the allow. After taking, why you do degrees of freedom? Only degrees of freedom is helpful to test, to refer to the consult the standard tables. For the particular degrees of freedom, you will refer the standard table. Yes. Now, if the obtained value, we are doing a calculation, you are going to arrive at one value. If the obtained value is less than the table value, then you will accept the null hypothesis. Always you start right. When you want to, whenever you want to test a hypothesis, convert that in null hypothesis. Because null hypothesis is only verifiable. Null hypothesis is only statistically testable. Okay, I am giving a treatment to see there is a difference. Because so long I put so much of pain to develop the treatment I am introducing, I want to have the posters to be effective. Is it not? That is my effort. But when you want to test, you have to frame it as a null hypothesis. But inference, again go for alternate hypothesis.
Excuse me, madam. Null hypothesis, we can write the total explanation according to null hypothesis. Is there necessity for the alternative hypothesis to write there?
In the inference, you can write the alternate hypothesis. Yes. Inference. Yes.
Okay.
Yes. This treatment is effective. Since the posters value is greater than the treatment value, the treatment is found to be effective. That is alternate hypothesis. Inference. But only null hypothesis is testable.
Testing of hypothesis, null hypothesis.
Yes.
Testing of hypothesis, on the basis of the testing of hypothesis, whether they rejected or accepted, we will write. Whether they accepted,
It's no difference.
no difference. But is there any necessity to write the alternative hypothesis along with that?
Alternate hypothesis becomes a null hypothesis when you accept.
Alternative,
They are one and the same.
but these two are mandated to write. One is sufficient, or null hypothesis and alternate hypothesis, both of them should be right.
Generally in third chapter they will write the alternate hypothesis if the experimental research. In the fourth chapter they will test using null hypothesis.
in third chapter, alternative hypothesis.
Fourth chapter. Third chapter, alternative hypothesis. Because experimental work. You are introducing a treatment to find the difference only, no? You are putting so much of pain. You are developing a module.
What
you are
we
developing
write
a
in the third
treatment.
chapter, we are going to be testing in the analysis portion. Na? We are writing in the alternative hypothesis. Where
Fourth chapter also.
we have to test it for null hypothesis only. Na?
That's what testing of hypothesis in the fourth chapter through using null. When you develop the hypothesis, one sample t-test, when you develop the hypothesis in the methodology chapter, you will write it as an alternative hypothesis. Yes. For experimental work. Not for survey.
Okay.
Because survey people behave. I don't know how you behave outside the room.
Yes.
You will behave very nicely inside the room.
Outside.
Once the professors are out, I don't know how you will behave. So for survey type of research, it is not so. But for experimental type of research, we go for alternative. Because you refer to the previous reviews also.
The reviews also.
With reference to that only, you will write the
Already we
hypothesis.
discussed with
Always when you go
the
for
previous-
directional hypothesis, especially when you are writing directional hypothesis, you must have some references. Review should be there to write that directional hypothesis.
Right.
Clear? Yes. So when you are comparing, you will compare at two levels. This is very, very important. One is not 5 level, another one is not 1 level. Okay? Which is most
Common.
needed?
Not very.
Not one.
Not
Not one.
right, not
Not one is only needed. When you are not sufficed with, when you are not able to reach not one, you will go for not one.
Oh.
See, when you have gold, 24 karat gold is there, 22 karat gold is there. Your sister is going to,
Generally we are
maybe your brother is going to gift you for Women's Day. Do you prefer to have 24 karat gold or 22 karat gold?
22 then.
22? As a brother, he will give 22. As a sister, she will like to have 24 karat. Okay? Do you follow? Yes. So, the most is 24 karat is the pure gold.
Pure gold.
22 is less pure. Similar to that, not one is the best one. If not one, please go for not.
In social sciences, generally they are using not by level only.
No, we are going for not one. We seek for not one. If not only we go for not one.
You cannot
Okay.
make jewel with 24.
Huh?
You cannot make jewel with
Usually
24.
do pure 24 gold.
Only 22
But
can
that's
make.
They have
for,
to-
for,
they have to add the
for
copper
an
also.
investment we can have it. For the investment here we can have it for 24.
Investment purpose is for.
Yes. Okay. So not one. You check.
Right.
Check for the value for not one. If it is more than the table value, if your obtained value is more than the table value at not one level,
Yes.
you reject the null hypothesis and say there is a difference. Suppose at not one it is not more. Go for not 5 value. Always in the table, not one level value will be higher value, not 5 level value will be little lesser value. Do you get the point? So my value, the obtained value is not greater than not one level value. At least I'll check for not 5 level. Now it is more, again I can reject.
I have one doubt, please, here. For example, the same testing of hypothesis in not 5 level, calculated value is more than table value. Whereas in calculated not 1 level, calculated value is less than table value, then what can we do?
I will refer to only not 5.
That's
That's not 5. I am going.
Is this one correct? Why? Because we are going for not 5 level. This is also correct, na?
See, I want to get distinction more than first class. When I opt for distinction, even distinction fellow is also first class fellow. Okay? Don't we claim I am distinction? Do we say I am first class? No. So since I didn't get distinction, I am saying first class. It is like that.
How can we choose? Oh, okay, this is not rejected. Okay, this table value is less than calculated value. So
Our purpose is to reject the hypothesis generally.
that generally.
Generally.
Right.
Okay? Our
Okay.
purpose, because reviews all say there is a relationship, there is a difference. Reviews say like that, no? You are doing research to bring out some inference out of
And
it.
one more
To say
important-
no difference, why should we
And-
do no research?
One more important point, ma'am. If you testing the all testing of hypothesis, can we choose only either 0.05 or not 1? Some hypothesis testing may be not 5 level, some hypothesis
That is
may be
permitted.
not-
That is permitted.
Okay.
There is no hard and fast rule that all the hypotheses should be rejected not 5 level. Or should be accepted. No.
Okay.
Both are permitted. Both are accepted levels. Okay, seek for not 1. If not, go for not 5. If you are able to satisfy not 1, well and good. Very good researcher. is this not one level? Not one level means when you conduct the experiment for 100 times, 99 times your results are true. Your results are valid. At least only 1%, one time, one occurrence, it will be false. 95% confidence level is when you repeat the experiment for 100 times, 95 times your results are true. 5 times it might happen to be false. This is the understanding about the level of significance or confidence. Okay? Yes. Next one. Lamp is dimming. What about no power?
At the same time, p value also how to testing. Already you have written there.
Previous?
Yes, p value. How to reject and how to. That also very important. P value.
So when you are applying SPSS, you are applying.
We know what is meant by p value. What is meant by p? Right. What is meant by p? Probability value. That's why please explain.
See, when it's probability value, when the probability value is less than 0.05, you will reject. This is reverse to the previous one. Okay, when you obtain what is less than the table value, you will accept null hypothesis. Isn't that earlier I said? When the obtained value is less than the table value, you will accept. When the obtained value is greater than table value, you will reject. But when it's real probability value, when the probability value is less than 0.5, you will reject the null hypothesis. When the probability value is greater than 0.05, you will accept null hypothesis. All the SPSS practice, SPSS, even not 5, not 1, even they say not 2 also. When SPS output you see, they say P less than 0.02. Sometimes they say P less than 0.0001.
In this regard, my intention is how to compare the students. For example, if you take t-test, calculated value and table value is available. In this regard, p value, how to check it, how to calculate? Can you say p value is greater than, is less than, already is there. How to check it? P value is 0.05 level. For example, you could take t value, calculated value, and the critical value is there. Here, how to compare this one? That is minute points also. If you say, we will get, our students will get paid.
This one, this p value is less than 0.05. It is more probability of is going towards the null hypothesis. That is detecting the null hypothesis. Okay, because the p is what to say, very close to the accepting the alternate hypothesis. When p is greater than 0.5, that is very close to the accepting, that is close to rejecting. This P is generally used only for statistical output of SPSS or AMOS and all. But when you are doing manually, we don't go for P. We only using the DF and consult the standard tables.
Ma'am, I have thought between this T value and P value, which is better to compare?
If you are doing using softwares, go for P.
Okay, the testing of hypothesis generally previous days, those days they are using
They
P
just go
value.
for P and not they never go for P.
Nowadays everybody is using the P value.
That's what, only the P value is obtained only in the SPSS zone.
Software.
Softwares, not a manual version.
Okay.
Manual working will not give P value. We will only refer to not 5, not 1. That's all.
Okay, that's
Okay, this because that minute calculation is given only through softwares. Not 2, not 1, not size. So P0001 they say. Okay, so that section also they say.
clinical experiments. Yes.
Okay, but not manually you can't do for P less than 0.05 or 0.01 for manual calculations. Only with the software, either AMOS or R statistics or
They are
SPSS.
using SPSS.
Yes, SPSS they can give you P values. Clear? Yes.
P value greater than 0.05.
Less than greater than 0.05.
Less than 0.05. How can we?
It will come in the output. The output will say. The output will be saying whether it's greater than less than. I don't have the output now.
No, for example, if you calculate T value is 3.47, calculated T value is, for example, 4.72. Okay, calculated. How can you compare? T value or something, calculated value 4.7. You compare with
Not accepted, sir.
why? How to compare?
0.05
Is greater than 4.5 or 0.05 is greater than 4.5 or less than 4.5? directly the significant level we are going
Yes,
to map.
yes.
Yeah, now
Yes.
this is not referred to the obtained value.
Yes.
This is the probability value of the standard table.
Yes,
Standard
this is the standard
value,
table.
this is
Ah.
only.
Yeah.
How to compare the calculated value they are asking.
This cannot be comparing is done by software with the table. The reference value it will not give in there show in the SPSS. It will only say whether P is less or greater. See, 1.96 value, standard value we know when you are manually
P value is
doing.
one.
That kind of thing will not be given in the SPSS software output.
Okay, ma'am.
Yes.
For example, if it's 0.05 level,
Ah.
1.96 is a standard value, T critical
See,
value,
this is
or
just
table value.
CR value you are getting the
Critical
output.
value or table value.
Ah.
Calculated value I am telling.
This is calculated value.
This is calculated 4
Okay.
point. If you compare,
It will give
0.02.
0.02. It will give like this. It will give like this. The software output will give like this.
Okay, there is no standard format.
No. The
not
software
so.
internally they have done programming to give this.
So whatever it gives, we have to depend only on that.
But this is giving based on the standard table. Okay, since it's going to be 0.02, this is lesser or greater?
Lesser.
Lesser. What will you do? Reject the
Rejected.
answer.
But because
So accept
calculated
that.
value is a high.
Suppose P is greater than 0. P is given as 0.62.
It will be accepted.
Because if P is greater than 0.05, so H0 is accepted.
Accepted.
They refer to the standard table, the P will be indicated. Okay, it is nothing to do with this. It says whether it is accepting or rejecting. It is only with reference to the tables, not with this. Clear? Don't compare this with P value. No. Don't compare this value with the P value. No. Clear? Okay. Next slide. Here you will find I have given the two means are given. Boys and girls. So this is independent because large sample the n is greater than 30. So 49 and 64. N is greater than 30, so large sample it is. So find out the sigma d, standard error of the deviation. It is square root of sigma n squared plus sigma m2 squared. Sigma m1 is sigma 1 by root of n1. Sigma m2 is sigma 2 by root of n2. Apply that, get the standard error of the deviation. Okay. You are getting that to be 1.15. Do you follow this? This is quite simple. Okay. This is standard error of the deviation. Sigma m1 square, sigma 1 by root of n1, sigma 2 root of n2, get these values and then apply this formula, get sigma d, which is 1.15. CR is m1 difference m2. 26.20 minus 23.28 divided by 1.15. So you are getting it as 2.539. Now find out the degrees of freedom.
Here CR means ma'am, abbreviation.
Critical ratio.
Critical ratio.
Critical ratio.
Now why because I am asking CRC dot or small r or capital R?
Capital R. When it is a large sample, we use the notation CR. When it is a small sample, we use T. Small t. When the sample size is more than 30, we say critical ratio. When the sample size is less than 30, we say small t, T value. In the table itself, we say T value. Don't put capital T. Capital T
Ma'am,
is
CR is used for the correlation, ma'am.
No.
Comparison.
No. It is small r, capital R.
Small r.
Correlation is small r, capital R.
Small r is meant for correlation.
Yes, capital R is also meant for correlation. One is PMS rank correlation, another one is Pearson's product moment
Product
correlation.
method. Yes.
Okay. So, CR, you are getting CR, find out the degrees of freedom. Now I have got some value 2.539. I should know whether I accept or reject the line policy. What should I do? I should go to the table. In order to go to the table, I must read DF, degrees of freedom. Degrees of freedom is N1 minus 1 plus N2 minus 1. First sample is 48, 49 minus 1, 48. Second sample is 64 minus 1, 63. The total DF is 111. Cancel the table. Okay, you refer to the table. Standard T table is there. For the degrees of freedom 111, again two levels are there. What are the two levels? 0.051, 0.01 level. Since the updated CR value is greater than 1.96, because it is a large sample. Large sample, you will not go to the table at all. You have to by heart the numbers. 1.96 for 0.5 level, 2.58 for 0.1 level. You have to by heart. For large sample, don't go to the table. You memorize. Okay, 1.96 for not fail level, 2.58 for not one level. Ours is 2. It is less than 2.58. I am trying for not one, but it is not higher. So I am going for not fail. Now it is higher than 1.96 or not fail level. So what do? You reject or accept? You reject the null hypothesis at not fail level. When you are accepting, don't write the level at all. You know pretty well, when you are accepting, it is not fail level only.
Okay, it's understood.
It's understood because not fail level is there, you will go to that value.
You can indicate simply single star, double star.
And that star you can indicate when you write the inference. There is no significant difference between boys and girls in their achievement. Hence, the null hypothesis is rejected at not fail level. Don't write the level for writing inferences when you are rejecting null hypothesis. When you are accepting null hypothesis.
Why, ma'am?
Because it is not fail level, it is less. That's why you are accepting.
On what basis you are rejecting, the explanation should be right, ma'am?
No, sir. My question is.
Okay, understood, ma'am. There is no need to write the rejection of the cause. Not fail level, this is the...
You are accepting.
Yes.
Suppose your value is 1.72.
At not fail 1.96.
It is less than 1.96.
Okay.
So it is not significant. I am accepting H0.
Yes.
Don't write the level. If there is a level, I should have written rejected at not fail level. Whenever you are rejecting, it is understood, it is at not fail level also, it is accepted.
Okay.
Because this is less than not fail level, also less than not one level. When will you accept? Only it is less.
Not fail level. Not one level is more priority.
No.
What are you doing?
Yes, not fail I am not getting, I am trying for not fail now. Even at not fail it is not giving me the favorable one. So I am accepting. When you accept, it is automatically understood. Not fail level, it is not favoring. Otherwise, I will reject it not fail level now. Suppose if my value is 1.98.
Yes.
What will you do? If your p value is
rejection null hypothesis, accept the alternative hypothesis.
your value is 1.98.
96 is 98
fine.
is greater than 1.96.
What
So null hypothesis can rejected.
Yes, null hypothesis is rejected. Now
Alternative
I
hypothesis
will write,
accepted.
now I will write it is rejected at not fail level. Because I cannot claim for not one level here. It is not, it cannot be claimed at not one level.
Yeah,
So
yeah.
I am writing the level.
Okay.
But when it is less, it automatically indicates it is less at not fail level also. That's why don't write.
Yeah, it sense. If
Okay.
you go for 0.01 level, there is no need to write 0.05 level. That's
Yes.
it. Right.
Okay. Yes. This is how you will write the inferences. Understood? I give inference the value of C is greater than the table value 1.96. At not fail level, we reject null hypothesis and conclude that mean performance of boys is significantly superior. That word significantly is very important. Significantly superior to that of girls is very important. That word significantly is very, very important.
I have one doubt, man. My doubt, na, on behalf of students,
Students,
I would
okay,
like to
okay,
ask
okay,
one
okay.
question. What is the need of testing of t-test? For example, if you comparison between the two means, if you see boys mean value is 26.20, girls 23, we can say boys is more better than girls. That we can say.
Yes, it's a very valid question. What is this question? Why to go for all the
How about
statistical?
t-test? Why?
Okay. See, the mean itself says it is
Comparison
23.
between two means you are go for
See, it is
t-test.
23.
Already
It is
said.
26. See, the variance varies. See, the variance doubles.
Yes.
The deviation from the mean doubles. And the n also varies. Okay, all these things will have influence on the result. We are not deciding anything based on the mean alone. Okay, this difference exists because of so many other mistakes committed by the researcher. One is, while administering the tool, as I told you in the morning, you must have helped the students. Thinking that these students are very poor, they can't understand my English, I can help them in the vernacular language, help them to write, put the tick mark in this way, one. In the other schools you went out, there you were given extra time for students to complete the questionnaire. The time limit for complete the questionnaire is only 20 minutes. But you would have given extra time, maybe 30 minutes. This will include error. All these things will bring out error in your research. Those things will reflect on the mean. That is why to limit those errors statistically, we are doing this. Standard error of the deviation. I want to statistically get rid of all these errors committed by the researcher or committed by the subjects while undertaking the research. Knowingly, unknowingly, definitely human error will be there in any social science researchers. That need to be removed. That need to be eliminated. As a human being, we can't do it. So statistically, we are trying to neglect all that. After that, we are trying to see whether there is a difference. Removing all the errors only after that, I could see the difference. Do you get the point?
Okay, ma'am, I understood, but
This first one is
my
what
students,
Yeah,
see,
first
are
one
they
is what
clarified or not, I can't understand. Simply we can say generally we are using t-test for comparison between the two means. Two means you can say boys is better performance than girls. We can say like that.
బట్ ప్రూఫ్ చేయాలి కదా సార్ ఎలాగాని స్టాటిస్టిక్స్
సార్ అక్కడ ఈ డిఫరెన్స్ ఉందంటే సార్ ఏ లెవెల్ డిఫరెన్స్ ఉంది ఆ డిఫరెన్స్
No. Why? Because the main purpose of the t-test is comparison between the two means. Madam already clearly explained not only two means, other two components are there. One is the standard deviation and number. According to that, generally, simply we say what we say. The comparison between the two means we are using the t-test. Not only this criteria, we have to consider remaining two also. Then only you will get the correct proportion to which performance is better.
Yes. Okay? Understood? Yes. Next one. This is independent sample. Independent means small sample. Similarly, independence means small sample means when the sample size is less than 30. When the sample size is less than 30, we say it's small sample. Then the formula is n1 minus 1. See the formula, instead of root of n1, we are given root of n1 minus 1. Understood? That's small variation. In the first formula, it is root of n1. Remember? Sigma m1 by root of n1. Sigma m2 by root of n2. Now in the small sample, instead of n1, we will write n1 minus 1, n2 minus 1 because sample size is small. When you say sample size small, when n is less than 30. Now when n is less than 30 in both the cases. So small sample. So slight variation in the formula. So now you have to refer to the table. Now I cannot use 1.96, 2.58. For small samples, after finding degrees of freedom, I should consult the standard table. The standard table is available in the book. You have to, so degrees of freedom here is 70 minus 1, 16. Here 9, 25 is the degrees of freedom. For 25 degrees of freedom, what is the p value? What is the value at 0.05? Refer to that. You will get that value as 2.06 here from the table. So I am checking for the value. The obtained value is 1.77. Obtained CR value is 1.30, value is 1.77. Since 1.77 less than 2.06, you accept the null hypothesis and conclude there is no difference between. Understood? There is no significant. That word is very important. Significant. To say whether it's significant only, you are doing all the statistics. There is a difference. See, there 32, 27, there is a difference. Is it really significant difference? Removing all the errors committed by me, committed by subjects, removing all that, is there really difference? That significant word is very important. For significant only, you are doing all these calculations. Understood? Yes. Right, next one. Next slide. This is single group design, one sample t-test. So here there's because same sample, there's a relation. Pre-test, post-test. Pre-test, one test is conducted, treatment is introduced, post is conducted. You are conducting the pre-test, the same test you may give as a post-test also. Is it not? Similar type of questions. The students will remember certain answers. Yes or no? Once the exam is over, you will consult with your friends. She should have told you, no, this is only correct answer. So when you conduct the post-test, it will click at your mind. Oh, that day she told me that's the correct answer. So that influence will be there in the post-test. So there is a relationship between your pre-test and post-test scores. They are not totally different one. That is why you are getting R value. You will have some relationship. Whereas previous tests, they are independent, but totally independent. Girls are different, boys are different. So their scores are different, they score here, same group, same test, pre and post. Before treatment, after treatment. So there is a relation between the scores. So R value is given. So when the R is given, you have formula sigma D is sigma m1 square plus sigma m2 square minus 2R sigma m1 sigma m2. So this you will not find in the earlier formula. Remember, this will find a new place here. Because there is a relation between the values, the pre-test scores and the post-test scores. So use all that, you will get a sigma D, apply the formula, get again degrees of freedom, only N1 minus 1, one same group. Same group is given test 2 times. So only N1 minus 1. No N1 minus 1 plus N2 minus 1. Because one single group it is, one group design it is. So for the degrees of freedom, refer to the table, you are getting right into inferences. Always seek for, even here, I could have seen, here I could have gone for not 5 level also. I have given not 5 level, I could have gone for not 1 level also here. I didn't check, I must have given not 1 level. From table value of T, for T of 25 at not 1 level, degrees of freedom is 31. Not 1 level is 2.75. It is only 7.83. No, even at not 1 level it is significant.
T value.
Yeah, T
0.05 level.
0.01 level.
0.1 level. How much, ma'am?
2.75.
Sir, 2.75. So, null hypothesis is rejected.
Yeah. At not 1 level also it is rejected. What I am saying, first go for not 1 level. If not, go for not 1. Always first check for not 1. That is more favorable.
In social
Because
science,
99% you are accepting the research. That's what I am. 99% is my research is true, I am proving. More than 95, I want my research to be true for 99%. That is more favorable for me, no? That's why always go for not 1. If not, go for not 1. Even a not 1, it is true. You are rejecting the hypothesis. Clear? This is for the single group design. Next slide.
It is the same if you take set of 2 groups, 32 minus 2, that is equal to degrees of freedom 30. Okay, n minus 1 degrees of freedom, if the, for example, another group, degrees of freedom is 30, na?
No,
This is okay. These are degrees of freedom. Two groups
are N1 minus 1 plus N2 minus 1 only.
Yes.
No, not N1 minus 2. Because group size will vary.
N1 minus 1, N2 minus 1. That's
okay.
Yeah.
Yes. The next one. Now, so this I have given. This is how you present the table in the thesis.
Yeah, yeah.
Okay. P is less than 0.01. I want to tell you only this P. P is less than 0.01. So like nowadays
directly we are comparing that level of P, or is there any P value?
no, this is the level of P. This is only level. It indicates only level, no P value.
Yes, that's what I'm asking.
No, this is only level
Yes,
of P.
level of.
Okay, so at not 1 level, this is true. Your findings are true at not 1 level also.
Directly we are comparing 0.01 level with 7.83.
That is only level.
Level.
No, you are not comparing this value with this. No. For this not 1 level, there is a value.
Yes. Please once again check.
This is 2.75.
Yes.
2.75.
Yes. Well, is it possible that net मध्ये आहे का तुम्ही P value द्रष्टुम?
T table, standard table of T.
This is very important for your PhD work. This is very, very important. 5 minutes it may go, please, they will get a concurrent.
No issues.
Everybody will get it, there is a doubt.
P value option. P value.
Yes.
Table.
P table value. How to see?
Not P, T, T.
T table values PDF. PDF ನಾನು clean ಆಗಿ download the PDF.
Sir, madam, English which one picture?
The first one?
Zoom.
PDF போடுங்க வரும் clean ஆ வரும்.
Oh, it's image. As you said, with your PDF, that's better. PDF.
Detail.
University website.
Now for the degrees of freedom, 31. After 30 you are getting at 40, is it?
Yes.
40 not 5 level you see. Go up you will find. Little reduce the percentage. You very much zoom.
Zoom out பண்ணுங்க.
minus.
Now you see for 40. No, let it be. No, little more, little zoom out.
Yes.
See for 40. 40, what is that? Not 5, not 1. See, not 1. Not 1 this.
The 40. The next to the blue. 2.473. 2.473.
423.
Sorry, 423.
2.423. Your value is higher. Somewhere 7 point, no? The obtained value. See, these are the P values. Not 1 level, not 5 level, not 1 level, not 1. This is for 1 day test. If it is going to be 2 day test, not 1 level, not 5 level.
But ma'am, the title is a T table.
Yeah.
But we are using the P in the name of
P
T.
value is reference, that is the probability value.
Okay.
For this probability, this is the value. It is nothing to do with the obtained value. 7 point, we got 7 point, no? 7.8 to something. It is nothing to do with that. To what extent this value is lesser than the table value? In which probability level? That is P level.
What is the use of instead of T value P? Directly we can write T value, table value.
How to refer the standard table? To refer the standard table, we need P.
Leveling with significant level is there, na?
That's all. Not one level. Not. This is one time test, not level. 2 time test,
That is a not level. T value.
This is only T value. This is a P
That is
value.
a significant level.
The significant level is only P value.
Okay, significant level is only T value.
Value. Not 5 level significant or not 5 level significant or not 1 level significant. Significant level is only P value. Okay?
Yeah.
Yes. Next one. We go to the PPT. Next I will go to ANAVA. ANAVA is very big process. Yes, next one. How to do? Paired sample. Suppose it is a paired sample data. There are 2 samples. Okay, matched pairs. I'm selecting the groups. Assign here one, assign there one. Instead of one sample, even experiment I can do experiment add samples. When it's a paired sample data, there's a small difference. 1 minus R squared. Sigma m1 squared plus sigma m2 squared into 1 minus R squared. So standard deviation formula will vary. Just other things are the same. If it is a paired sample, there is a slight variation in the standard area of the deviation value. Clear? Matched pair design. You will have 2 groups, equally matched in all respects. You introduce one treatment here, one treatment there, and see which is better. Understood? Okay? Yes. Next. That's all. Z test morning I taught. Maximum I told in the Z test morning. Remember? Z scores. You are converting the Z scores and finding out that. This you still skip all this. Please skip. Skip. Go. You know this formula morning we discussed. X naught is mu by sigma. Remember? Skip. Skip. Go now. This is going to compute. On a measure of anxiety, group of participants show a mean score of 35 with a standard deviation 5. What is the result score corresponding to the score of 30? You convert that into standard score. It is 1. Morning we did, remember NPC. Left. Okay, left it is. Next. Now, in mathematics, see, this is how the result test is generally used. In maths test, with a mean of 81, standard deviation 12, Vignesh scored 72. He got 29 in science with mean of 83 and SV of 8. In which test he did better? See, the value changes. Mean changes, standard deviation changes. In maths test, Vignesh is getting 81 marks. Mean of the maths test is 81, SV is 12. Whereas Vignesh in the same class, Vignesh scored 72 as max mark. But in the science test, the mean is 33, SV is 8. What will be the equivalent score? He got 29 in science. Where he fared better? Science or maths? Because mean vary, SV vary, marks also vary. How can I compare? Convert that into result score. Morning I told you, no, 20 marks you are giving a test. Another class you are giving 50 mark test. How to compare these two? Convert to 100. Then compare. Similar to that. Now mean varies, SD varies, he has got 1 mark. Another test again, mean varies, SD varies, he has got another mark. Which subject he did better? Come to a common platform. Common platform is result score platform. Convert that into result scores. Compare them. The result mathematics is getting 0.75. Result science is getting minus 0.50, minus 0.75. Which is a higher value? Why? See, max is minus 0.75.
Yes.
Science it is minus 0.50. Which is higher value?
Science.
In the minus, lower values are higher
Yes.
magnitude. Higher values are lower magnitude. Is it not? See, in mathematics, is minus 3 bigger or minus 5 bigger? In mathematics, is minus 3 bigger or minus 5 bigger?
Minus 5, ma'am.
Minus 3 is only bigger.
Minus 5%.
Minus 3 method.
Okay, so in this, which is higher value then?
Minus 0.5.
Science. So he fared better in science than mathematics. Do you follow? In negative values, the lower value get a higher magnitude. Isn't that minus 1? Yes. This is how result score is used to compare two distributions. This is the main importance of result score. Yes, next slide. Similar to that, in a CBSE is getting so much of marks, in material what will we get? When you go to SSN and all, I don't know whether you know SSN college in Tamil Nadu, even though they do CBSE and other things, even matriculation students will apply, CBSE students will apply. They will convert that into standard score, they will prepare a good quiz. They will admit the students. Because CBSE cannot compare with matriculation. CBSE is in the higher standard, getting marks is difficult compared to matriculation. Or matriculation students are getting 100, but it's also easy to get in 100 in CBSE. But how can I compare? CBSE 90 is not equal to matriculation 90. Do you agree with me?
Yes, ma'am.
Okay, so they have to come to a common platform. They go to result score. Convert that result score and draw a merit list. That's the application. A person is getting CBSE, he scored 60 marks with a mean 45 and SD 10. Compute the score he would obtain in matriculation pattern as the mean and SD 70 and 12 respectively. What will be his score? Compute, he is getting 88. A person is getting 70, 60 in CBSE can get 88 in matriculation for this mean and SD, I am saying. Not everywhere. Do you follow? So this is the application of result score. Understood? Yes. Next slide. My second session is over.